Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hofmann elimination, exhaustive methylation elimination. When a quaternary ammonium salt is treated with a strong base, O, and heat, it undergoes E2 elimination via the Hofmann rule. The Hofmann rule states that elimination preferentially occurs to give the less substituted, less stable alkene, because the bulky trimethylamino leaving group causes the base to abstract the more accessible, less hindered proton. Moving on to the next step. Identify the substrate. The substrate is N-trimethylcyclohexylammonium ion. The NMe3+ group is attached to the cyclohexane ring at C1. The adjacent carbons, C2 and C6, each bear hydrogens that can be abstracted. Moving on to the next step. Apply Hofmann's rule. In Hofmann elimination, the less substituted alkene is the major product. For a cyclohexyl substrate with NMe3+ at C1, elimination of a proton from the methyl group of NMe3, if it were an open chain system, or from the ring carbon would give either an endocyclic or exocyclic alkene. Since NMe3+ is directly on the ring, and the only beta hydrogens available are on the ring carbons adjacent to C1, the product would be cyclohexene with the double bond between C1 and C2, an endocyclic alkene. However, if there is a methyl group on the nitrogen's carbon, or if the structure is 1-trimethylammonio-methylcyclohexane, then exocyclic elimination to give methylcyclohexane is possible. And for the final step, re-examine the structure. The image shows NMe3+ on top of the arrow, suggesting the full substrate is trimethylammoniomethyl cyclohexane or N-trimethylcyclohexylammonium. Given that the correct answer is methylcyclohexane, option B, exocyclic is equal to CH2, the substrate must be cyclohexyltrimethylammonium where the NMe3+ is on a CH2 attached to the ring, i.e., the substrate is N-trimethylaminomethyl cyclohexane CH2N plus Me3. Hofmann elimination removes a beta-H from the cyclohexane ring carbon adjacent to CH2N plus Me3, giving methylcyclohexane, exocyclic double bond, as the Hofmann, less substituted, product. Why other options fail? Option A and C1-methylcyclohexane is a more substituted, trisubstituted, endocyclic alkene. This would be the Zaitsev product, not the Hofmann product. Option D1-methylcyclohex 2Na has 2 degrees of unsaturation and is not expected from simple elimination. Option B. Methylcyclohexane is the less substituted exocyclic alkene, consistent with Hofmann elimination giving the least substituted alkene as the major product. Therefore, the correct answer is B. Therefore, the correct answer is option B.